Okay. Today we're going to talk about using dot plots and using a box plot, sometimes called a box and whisker plot, to make an inference, to make a judgment or an educated guess about a group of statistical things that has been gathered. Okay? So if you take a look right there on the front, you're going to see this. After obtaining a random sample of a population, first off, they told me that my sample was unbiased, that it was random. You can make inferences about the population. Random samples are usually representative and support valid inferences. What would make them invalid inferences? If the sample was what? Biased. Then you couldn't make a good inference from it. Rosie asked students on the lunch line how many books they had in their backpacks. She recorded the data as a list, 261041422. Make a dot plot for the books carried by this sample of students. So, when we come down here on my box plot, I want to start at what? 0, and I want to go all the way at least to what? 6. So go ahead on your number line. 0, 1, 2, 3, 4, 5, 6. When you are using a dot plot, you simply put a dot every place you see a piece of data. So I'm going to start at the beginning. 2. I'm going to put a dot there. I'm going to cross that out so I don't get it again. Then I'm going to go to what? 6. I'm going to put a dot there. I'm going to cross it out so I don't repeat it. Then I'm going to go to 1. I'm going to put a dot. And I'm going to keep doing that until I've exhausted this list of data. By the way, it says order the data from least to greatest, which the reason they said to do that was so you'd know what numbers to put on there. So from least to greatest, it would have been 0, 1, 1, 2, 2, 2, 4, 4, and 6. Draw a number line from 0 to 6. Place the dot above each one. Notice that the dot plot puts the data values in order, doesn't it? What's the least amount of books that everybody carried? 0. What's the most? What 2 values did nobody carry? 3 or 5. Do you think anybody in the school might have carried 3? It's just nobody she surveyed carried what? 3. So, if you look down, it says, how are the number of dots you plotted related to the number of data values?
They're related because the dots equals is every person she's surveyed that has that number.
So mathematically, what would we say? They are what?
Equal?
They are equal. They're equal. They're the same. Each dot represents a piece of data. Yeah, there's another box there. There's a box right there. Complete each qualitative inference about the population. Most students have blank 1 book in their backpack. If they want me to put a qualitative value, do they have less than 1, at least 1, more than 1? What can you tell me by looking at the plot? Most students have certainly at least what? At least 1 or more than 1. So either one of those you could use. At least, or you could have put have more than one book in their backpacks. Most students have fewer than how many books? I could say 3. That's more than half. 1, 2, 3, 4, 5, 6 people, right? There's 6 people here and only 3 here. Most students have fewer than what? Than 3 books. Most students have between how many books in their backpacks? Again, remember, most has to be over half to be most. Right? How many total people were here? How many total people? 1, 2, 3, 4, 5, 6, 7, 8, 9. So to be most, it's got to be at least what? At least 5. So I could say 1 and 2, there's 5. I could say 2 and 4, but I certainly can say what? One and 4, right? Most people have between 1 and 4. What could Rosie do to improve the quality of her data? What'd you say? I agree, different students, but something more specific than just different. If you want to increase the quality of your data, you're almost always going to have to ask more people. Only getting to talk to 9 people out of the people in the lunch line is probably not a very representative part of the people going through the lunch line, is it? Okay, everybody okay? We understand how to make a dot plot. Okay? You need to put them in order from least to greatest so you know where to start and where to stop your number line. And you simply put a dot on each one of those pieces of data.
So it's not the same as yesterday.
Not the same as yesterday. Everybody good? Now we're going to talk about using a box plot. Anybody do a box and whisker plot last year at all? I can't remember whether we did it in here at the beginning of the year or not, but I think by now you should have seen a box plot at some point. Okay. So, again, there are things that we can infer from a box plot. There are different things that I can get from a box plot than I can from a dot plot. Likewise, there's things I can get from a dot plot that I can't get from a box plot. So, the first thing it says is order the numbers from least to greatest. So let's take our list of numbers. What do I want to start with? 0. What's my next number? How many of them are there? What's my next number? There's 2 of those. What's my next number? Then a 5, then a 6, and then a 9. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of information. Okay? First thing you need to do when you're making a box plot is put things in numeric order. At the bottom of your box plot is always the lowest number. What's the smallest number that was there? 0. And they've already put that number. You see it. It's kind of in green there on your sheet of paper. Everybody see it? The 0 is there. The next thing you always look at is what's the greatest number that was in my list? 9. So let's go ahead and fill that in. Now, the nice thing about making a box plot is that you're always using The median. The median is what? The middle. Okay? So we work our way from the outside to the inside. If I got rid of 0, I'd have to get rid of the 9. If I got rid of the 2, I'd have to get rid of the 6. If I got rid of the 2, I'd get rid of the 5. If I got rid of the 3, I'd have to get rid of the 4. What's directly in the middle of this data? And specifically that 3. So go ahead and put it in the middle. 3. By the way, I could go ahead and fill these in. Right? Quartile.
Oh.
Quartile. And I'll talk about that in a minute. Okay? Listen. Once I found that this was my middle, and this number got used, then what I find is the middle of this half. So if I got rid of the 0, I'd have to get rid of this 3. And there's 2 numbers then that are together in the middle. So in order to figure what that is, I'd have to take 2 plus 2 and divide it by 2, which is what? 2. Okay? Okay, does everybody understand that? This would have been 2 plus 2 divided by 2. This was 3. What am I going to do over here? 5 plus 6 divided by 2. Again, it's the middle of this upper piece. So 5 plus 6 divided by 2, which is 5.5. Okay? Now, on your number line, you're going to number from at least 0, and since this one went up to 10, I labeled it all the way to 10. So, put the numbers 0 through 10. The numbers that we found, this 0, this 2, this 3, this 5.5, and this 9, are what outline my box and what's considered my whisker. Okay? So at each one of these values, 0, 2, 3, 5.5, and 9, I'm going to put a dot at 0, 1 at 2, 1 at 3, 5.5 is going to be between 5 and 6, and 1 at 9. And I'm going to connect all of those dots with a what? With a line. In the middle, these 3 dots that are in the middle, we're going to put a box around them, and then we're going to draw a line down. Okay? So your box plot should now look like this. You can label this first part Q1, Q2, Q3, and Q4. Quartile means what? Quartile. How many groups do I have? 4. Quarter. 1/4. So, the nice thing about looking at a box plot is, let's not talk about what's up here on this end for a minute. Let's forget about it. Let's just forget about it for a minute. How much of my data is here, percentage-wise? Does anybody know? Yeah, from Q1 to the beginning of Q2, how much of my data, percentage-wise, is there? 25%. 1/4. Okay? Let's forget about everything except Q2. How much of my data is in Q2? 25%. How much of my data is in Q3? 25%. How much of my data is in Q4? 25%. Listen, so often when people are looking at a box plot, sometimes you'll get part of the box that's really short or part of a box that's really long, and they think the long part of the box has more data in it. That's not true. It just has a larger range. What does range mean? From the bottom to the top and you subtract the two numbers. What's the range of this whole thing? The whole thing. 9 minus 0 is what? 9. This part is called the interquartile. And this part is significant. How much of my data is in Q2 and Q3 put together? Say it. 50%. Half of my population is there in the middle. So if I was looking at trying to make an inference from this, the part that I'm going to be most interested in is what's inside of the box. The part that's out here would be less important, the part that's on the whiskers. That makes sense to everybody? Now, a good measure for the most likely number of pets. What do you think the most likely number of pets would be if this is what I had to look at? Where's the center? 3. Dead center of my group is 3. The most likely number of pets, then, is 3. Could I recognize Could I recognize the mode when things are displayed this way? No, because I don't know even if 3 existed in my data when I look at it, because 5.5 didn't exist in my data, did it? It just was the median of that piece. So, I can't find the mode, but 3 is the median of this group, and it's a good representation of how many pets each person has. 50% of the students have between blank and 3 pets. So if it's between something and 3, where could I find 50%? Between 0 and 3. 25% between 0 and 2. Another 25% between 2 and 3. 50% of my data is between 0 and 3. Where's the other 50%? If it's between 0 and 3, where's the other 50%? Between 3 and 9. Make sense to everybody? Almost every student in Parkview has at least that would only be half. This is 75% of the people. That's almost everybody, isn't it? So almost everybody has how many pets? 2. Does everybody understand that we might be able to infer different things from a box plot than we could from a dot plot? A dot plot, I can actually find an average because all of the data is there. A box plot, I don't see that. But it's easy to figure out where 25% of the data is when you're looking at a box plot. Not as easy to figure out when you're looking at a dot plot. we'd actually have to figure out where 25% would be. So there's an advantage to seeing it displayed in two different methods. One more method to make an inference. We can make an inference using proportions. Now, you're going to notice that they worked out an example there on page 319, and I've skipped the example part that they worked out. The part that I'm working out is the your turn that's below that. Okay? A shipment to a warehouse consists of 3,500 MP3 players. The manager chooses a random sample of 50 MP3 players. When you're setting up a proportion, you want to make sure that you're comparing like things. If I'm looking at defective, I want to compare it to defective. If I'm looking at the size of the sample, I want to compare it to the size of the population. Okay? So, how many MP3 players in the shipment would you predict to be damaged if 6 MP3 players in the sample had been damaged? So, 3,500 is the size of the population. What was the size of the sample? 50. Sure. How many defective is there in the population? Do we know?
No.
In the population. That's what we don't know. How many are defective in the sample? 6. Everybody remember working with proportions earlier this year?
Yes.
How did we do these? Anybody remember? Very good. Cross multiply. We're going to take 6 times 3,500 is equal to 50 times x. Somebody take 3,500 times 6. I think it's 2,100. 21,000.
Oh, wait, 35.
What is it? 21,000?
35.
6 times 3,500 is 21,000. How would I get x by itself? Divided by 50. Take that 21,000 you just had and divide it by what? 50. What is 21,000 divided by 50? So, it can't be 420 maybe. Why would I, let's go back to that for just a second. Why would I know that this couldn't be my answer?
Because it's bigger than that.
How much was the whole population? 1,500. Is it possible that I'd have more defective than I had total? No. I even question whether that's right or not. That seems high. But it is, that's right, 420 defective. So, 3 ways to make inferences. You can use a dot plot, you can use a box plot, or you can set up proportions depending on the information that they've given you. I personally like proportions because the answer is definitely a concrete thing. It's only one correct answer. anytime you're using a dot plot or a box plot, our answers may vary slightly, but they should be close. Questions? Your assignment today is page 320 and 321, 1 through 16.
It's not something